Right now, sitting perfectly still, you are being flung east at about 1,000 miles an hour. You feel nothing because the spin is perfectly smooth, like a jet at cruising speed. So what happens the instant it stops? First, a catch. Suddenly stopped can mean two very different things, and the difference is everything. Maybe everything halts at once, or maybe the ground stops and you don't. The honest, brutal version is the second one. The crust slams to a halt, but you, the air, and the oceans keep all that eastward momentum. Near the equator, that's 1,000 miles an hour. Anything not bolted to bedrock is thrown sideways. The whole atmosphere keeps moving, winds far past any hurricane, scouring the surface bare. The oceans keep moving too, sloshing free of their basins in mountains of water racing toward the poles. Your fate comes down to latitude. Your momentum matches how fast your patch of ground was already turning. At the equator, it's total destruction. At the poles, the ground was barely moving, almost eerily calm. Now suppose it stays stopped for good. Slowly, the map of the world redraws itself. The spin has been pulling the oceans outward, piling water about 8 kilometers higher at the equator. Stop spinning and that bulge collapses. Gravity drags the water toward the poles. Two enormous oceans drown the poles, while a dry megacontinent rings the entire equator. Places like the Amazon and Indonesia would rise from the water, dry and barren. Canada, Russia, and Northern Europe would sink beneath new seas. Then there's the day. Earth still circles the sun, one full lap a year. So a single sunrise to sunrise now takes 12 months. 6 months of daylight, 6 of darkness. The lit half bakes for half a year, the dark half freezes. The temperature swings are savage. Deeper down, Earth's molten core churns like a dynamo, and the spin helps stir it into a magnetic field. Weaken that spin, and the field could fade, our invisible shield against solar wind and cosmic rays. Without it, more radiation reaches the ground, and over ages the solar wind can strip the air away. None of this is coming. There's no break on a planet, and its spin, its angular momentum, has nowhere to go. Which is the real point. That quiet spin holds up our winds, our oceans, our map, and our shield, and we never feel it. So here's the puzzle. The safest place to survive the stop is the pole, but the pole is exactly where the new ocean drowns the land. Equator or pole, where would you stand? Tell me below.